square minus 6n plus 9 equals 0. No. Just m minus 3 squared, not plus 3 squared. So m should be equal to m minus 3 squared equal to 0. So m equal to yeah.
Now, okay, let's see. It's easy, okay? Here, the first one. So the first one, the axillary equation is actually m squared plus 6m plus 3m minus 4 equal to 0. Yeah. So here we can find the factor actually is m minus 1 times m plus 4 equal to 0. Yeah. So here, so m1 equal to what? So m1 equal to minus 1, m2 equal to what? Oh no, m1 equal to 1, m2 equal to minus 4. Yeah. So here the general solution is what? Y equal to e m1x, so ex of c1 plus c2 e minus 2x, m2x, so minus 4x. So the result is y equal to c1 ex plus c2 e minus 4x. This is the first one, okay? The second one is first the auxiliary equation should be m squared minus 6m, yeah? And plus 9 equal to 0, yeah? Equal to 0. So here we can find it actually is equal to m minus 3 square equal to 0, yeah? So m equal to what? M equal to 3, yeah? M equal to 3, so this is the second case. The second case, so the general solution should be yx equal to c1 e mx, so e 3x up, and plus c2 x times e mx, yeah? So this is the second, okay, second. So now for the third, okay, for the third here, the auxiliary equation is m squared minus 6m plus 25 equal to 0, equal to 0. So here we can see for this one, delta actually equal to b squared, so minus 6 squared, b squared minus 4ac. 4ac, so here is what? 36. 36 minus 100, so it's minus 64. Minus 64, so here m1 should be equal to 2a minus b plus the square root 64, yeah? So here the square root of minus 64 actually equal to the square root 64 times minus 1, yeah? So equal to the square root of 64 times the square root of minus 1. So the square root of 64 is what? It's 8. Square root of minus 1, I. So 8i, okay? So the result should be 6 plus 8i by 2. So the result is 3 plus 4i, okay? So the first root. The second root is what? m2 equal to 2, here is 6, minus the square root minus 64. So here should be 6 minus 8i by 2, yeah? So the result is 3 minus 4i, yeah? So here means a equal to what? A equal to 3. B equal to what? B equal to 4, yeah? So the result, so the general solution is yx equal to c1 e ax. Ax is 3x cosine bx, cosine 4x, the first. The second is plus c2 e ax, 3x sin 4x. Okay? So this is the result. So this is the end of chapter 9. Okay? And now I tell you.
Plus a1 equal to what? Plus 6.
Why?
A1 equal plus 6. There should be minus 6. Plus it,
Upper line.
yes.
6 by 2 is 3.
No, no. Why there is the plus 6?
अरे इसका कोर्स है वो उसना
Plus 6.
Yeah? 6, only 6. They're supposed to be minus 6.
But B on this equation, B is negative. Like on the equation, it's minus 6. Seven.
Oh, yeah.
Yeah. It's minus.
Here is minus b. Okay, so here minus 6. So, the important point of chapter 9 actually is the table of 432. So I think that you should remark it, okay? Here, 432, the table, okay, the table. This is the first. The second is the page 409. 409, the equation 5. So equation 5 and the solution 9. The solution 9. So the equation 5 and the solution 9, I think that you should remember it, okay? And for the separable equation is the equation 12. The equation 12 and the equation 14. These two, okay? You should remember it.
Sorry, say that again.
411, the equation 12, the separable equations, okay? The separable equations, equation 12. And the 412, the equation 14. The equation 14. Okay? So this is the end of chapter 9. So I think that for chapter 8 and for chapter 9, I should give you the exam. So the exam will be the last Tuesday night. Okay?
Next Tuesday.
Next Tuesday night. So here now we go back to the examination of the chapter 6 and chapter 7. Okay?
The exam was on the relation for what? 8 and 9. The exam was.
The exam of chapter 8 and chapter 9 will be in the next Tuesday night. Okay? Next. So here, for the second exam, okay, the highest mark is 92. Is 92, okay? The highest mark. And the lower, okay, and the lower actually is just 10, okay? Just 10. So this is the highest, this is the lowest, okay? So now I will. So now we see the exam, the problem, okay? The first problem is the antiderivative, okay? 3x to the 6th power minus 2x squared and plus 7x plus 1 dx. Find the antiderivative of this function. So here equal to what? So here now we can see for the first part. Here 3x to the 6th power. So here should be what? Should be 3x 6 plus 1. Yeah? By 6 plus 1. This is the first part. Yeah? And the minus. Here minus, so minus 2. Minus 2 here x squared. Antiderivative. So it's x 2 plus 1 by 2 plus 1. Yeah? The second part. And the third part, 7x. 7x is what? The antiderivative is 7x 1 plus 1 by 1 plus 1. Yeah?
Yes.
And the 1, the antiderivative of 1 is x. Yeah? So here we need to plus a constant c. So the result should be 3 by 7 x to the 7 power minus 2 by 3 x cubed. Okay? And plus 7 by 2 x squared plus x plus the constant c. So this is the first. The second is find the antiderivative of x cubed times ex to the power x to the fourth power. Okay, here dx. For this one, actually I want to test the u substitution. Okay, so we let u equal to what? We let u equal to x to the fourth power. Yeah. So here we let u equal to x to the fourth power. So du dx equal to what? So du dx equal to what? 4x cubed. Yeah. So here means du equal to 4x cubed dx, or dx equal to 1 by 4 x cubed du. Okay, du. So here now we can replace this. Here is x cubed. Here is e. X fourth power is u. So here is u power. Dx is what? Dx is 1 by 4 x cubed du. Yeah. So here x cubed, here x cubed. So cancel. Yeah. Here is 1 by 4 a constant. Moves to the integral sign. So the result should be 1 by 4. The antiderivative of e to the u power du. Yeah? So here e, the antiderivative of e to the u power is what? Is eu. Yeah? Is e to the u power plus the constant c. So we replace u by x to the fourth power. So the result should be 1 by 4 ex to the fourth power plus the constant c. So this is the result. Okay, this is the result. This is number 2, okay? For number 3 here, the cosine x cubed dx, the antiderivative, okay? The antiderivative. So here actually we have a reduction formula, yeah? So actually here, if you cannot remember the reduction formula, I think that it is easy, okay? So you can rewrite cosine cubed by square times cosine. So here should be the antiderivative of cosine x square and cosine x dx. Yeah? And now here, so we use the u substitution. We let u equal to what? Here this part, okay? This part actually we can rewrite it by d sin x. Yeah? So here actually should be what? Should be cosine x square and d sin x. Yeah, d sin x. Because sin derivative is cosine, yeah? So here cosine square d sin x. And cosine square actually is what? We know sin square plus cosine square equal to 1, yeah? So here cosine square should be 1 minus sin x square, so d sin x, yeah? So now we can replace sin by u. So here should be 1 minus u square du. Let u equal to sin x. So here is what? So the antiderivative of 1 is u. The antiderivative of u square is 1 by 3 u cubed plus the constant c. Yeah? And we replace u by sin. We replace u by sin, so the result is sin x and minus 1 by 3 sin x cubed and plus the constant c. So this is the result. you cannot take the figures, okay? Keep it in mind, okay? So you take it in figures, and in the second, so I will give you another chance, okay? If you are not satisfied for your mark, I will give you another chance. So if you want to attend the exam again, so you can find me the next Tuesday night. So next Tuesday night in my office, okay, I will give you another chance. So I think that you cannot take the picture, okay? Keep it in mind, and I hope that you can keep it in mind, okay? So now, for the second, evaluate the following definite integrals. The first one is from 0 to pi by 3 second x squared dx. So actually, this is very easy, okay? You just need to remember which function derivative equal to second square? Tangent, yeah. So here this is equal to what? Actually this is equal to tangent x evaluate at pi by 3 minus evaluate at 0, yeah? So the result should be tangent pi by 3 minus tangent 0. Tangent pi by 3 is what? It's square root 3 minus tangent 0 is 0, so the result is square root 3. The first one. The second one is the definite equal from 0 to log 3. Log 3 dx of 1 plus ex half dx. For this one, okay? For this one, actually, I want to test what? The same, the u substitution, okay? So that u equal to what? U equal to 1 plus ex, yeah? So here we let u equal to 1 plus ex. So du dx equal to what? So du dx equal to ex, yeah? So here we have du equal to ex dx, or dx equal to 1 by ex du. Okay? So here this is ex. So this part we can see ex dx actually is du, and here 1 plus ex is u. So here it should be u half power du. And now we can see where x equal to 0, where x equal to 0, u equal to what? Where x equal to 0, u equal to 1 plus e 0 power, yeah? 1 plus e 0 power is what? 2, yeah? And where x equal to log 3, where x equal to log 3, u equal to what? U equal to 1 plus e log 3, yeah? E log 3 actually is 3. 1 plus 3, so it's 4, yeah? So where x equal to 0, u equal to 2. So here this lower limit should be replaced by 2. And where x equal to log 3, u equal to 4. So the upper limit should be replaced by 4. So here we use u substitution here. So here it worked. So here we find the antiderivative of u half power. U half power, so here it should be u half power plus 1 by half power plus 1. This function evaluated at 4 minus this function evaluated at 2. So here half plus 1 is 3 by 2. 1 by 3 by 2, so here is 2 by 3. Here is u. Here is 3 by 2 power here is 4, here is 2. So the result is what? So the result is 2 by 3, here should be 4, 3 by 2 power, minus 2, 3 by 2 power. So 4, 3 by 2 power actually is what? 4, 3 by 2 power. 4, 3 by 2 power actually is 4, 1 power times 4 half power, yeah? 4 half power actually is the square root of 4, yeah? Square root of 4 is 2, so 4 times 2, so here is 8. Here is 8. And now we can see 2, 3 by 2 power. 2, 3 by 2 power actually is 2, 1 power times 2 half power. So here actually is 2, half power is the square root of 2. So the result should be 2 by 3, here is 8 minus 2 square root of 2. So the result actually is 16 minus 4 square root of 2 by 3. Okay? 16 minus 4 square root of 2 by 3. So this is the second one. For the third one actually is here. Is from 0 to 2. From 0 to 2 here is 1 minus x squared absolute value dx. Yeah? So here now, the key point here is we have absolute value here. So we need to eliminate the absolute value. So the absolute value here we can see 1 minus x squared equal to the absolute value. So here, in the interval from 0 to 2, from 0 to 2, in which interval 1 minus x squared positive, in which interval negative. So it's easy to see, yeah? So when x belongs to from 0 to 1, from 0 to 1 is it positive or negative? Positive, yeah. So absolute value of positive is also in the sign 1 minus x squared, yeah. And when x belongs to 1 to 2, so it's positive or negative? Negative. So absolute value negative. So here should be equal to x squared minus 1, yeah. So here, so it's easy. So here you first use the property here divided by from 0 to 1. Absolute value 1 minus x squared and plus from 1 to 2 1 minus x squared absolute value dx. Yeah? So first we use the property and then in this interval this absolute value actually equal to 1 minus x squared. So here should be from 0 to 1 minus x squared dx. The first one. And plus here is from 1 to 2. The absolute value of 1 minus x squared in this interval is x squared minus 1. X squared minus 1 dx. Yeah? So now for here, for the first one, what's the antiderivative of 1? X. What's the antiderivative of x squared? 1 by 3x cubed. Yeah, so this here, this is the antiderivative evaluated at 1 minus evaluated at 0. And plus here, the antiderivative of x squared, 1 by 3x cubed. The antiderivative of 1 minus x, evaluated at 1, 2 minus evaluated at 1. So the result should be what? Should be 1 minus 1 by 3 times 1 cubed. This 1 minus this function evaluated at 0, so this is the first part, and plus here is 1 by 3, 2 cubed, minus 2, yeah, and then minus 1 by 3 times 1 cube minus 1, yeah. So here now we can see here is 1 minus 1 by 3, so here is 2 by 3, this is 0, and then plus here is 8, so 8 by 3 minus 2, so here is 2 by 3, and here is minus, here is what? Here is 1 by 3 minus 1, so minus 2 by 3, minus 2 by 3, so plus 2 by 3, so the result is 2. The result is 2. So this is the answer, okay? Now we have the last equation, the last problem, okay? So for the last problem, actually I tell you I will test, okay? I tell you I will test. So if you can write the formula, okay, I will give you half marks. So for example, for the first one, if you write the formula, yeah, I will give you 5 marks. So now for the first here, for the function fx equal to 2 by 3x 3 by 2 power, okay? 3 by 2 power on the interval from 1 to 4, okay? From 1 to 4. So here, let R be the region of that is bounded above. So here we can plot it. We can plot it from 1 to 4. Here is 1, here is 4. So this function actually is like this. So this is the region, okay? So this is the region R. So here now, this is the first problem is find the arguments of the curve y equal to fx from x equal to 1 to x equal to 4. So the first thing here, the arguments, what's the formula? The formula is from A to B, the square root 1 plus f prime square dx. Yeah? So if you can get the formula, I will give you half marks. Okay? So here fx equal to here. So now it's easy to see f prime actually is what? F prime actually is 2 by 3 times 3 by 2 x 3 by 2 minus 1. So actually it's x half power. Yeah? So the result actually is from 1 to 4, the square root 1 plus x half power square.
So yeah.
Half power square, so here actually is x. So this, the first one is compute this definite integral. So the result is 1. So actually you can calculate your side, okay? It's easy. You can use the u substitution. Then u equal to 1 plus x. Okay? So the result is 2 by 3 times 5 the square root 5 minus 2 square root 2. Okay? This is the first one. The second one, so find the area of the region R. The area, okay, so the area actually is what? So the area actually is the definite integral, yeah? So the definite integral from A to B fx, yeah, dx, yeah?
Yes.
So here is from 1 to 4, 2 by 3x, 3 by 2 power dx. So find this definite integral. So 2 by 3 is a constant, moves through, so 2 by 3. And here is, so what's the antiderivative of, So this is x 3 by 2 plus 1. Here is 3 by 2 plus 1. Here. Yeah. Evaluate at 4 minus evaluate at 1. So the result is here 2 by 3. Here 3 by 2 plus 1. 3 by 2 plus 1 is 5 by 2. 1 by 5 by 2 is 2 by 5. 2 by 5 times 2 by 3. So it's 4 by 15. 4 by 15 x. Here is 5 by 2 power. Evaluate at 4 minus evaluate at 1. So the result should be 4 by 15. Here is 4 5 by 2 power minus 1 5 by 2 power. So the result actually is 124 by 15. 124 by 15. So this is the second one, yeah? The third, find the volume of the solid of the solution that is generated by revoluting the region about the x-axis. So here, the revoluting the arm about the x-axis. So what's the formula? The formula is the Vx actually is from A to B pi fx square px. Yeah? This is the formula, okay? So this is the formula, so revoluting r by x-axis. So here the result should be here from 1 to 4 pi. So this square is 4 by 9 x. Here is what? 3 by 2 square, so cube. Yeah? So cube dx. So the result is what? So the result here, pi 4 by 9 is a constant. 4 pi by 9. So x cube. What's the antiderivative? Is 1 by 4 x to the fourth power. Evaluated at 4 minus evaluated at 1. Yeah? Here is 1 by 4 is a constant. Who is rule here? So the result actually is here is 1. Pi by 9. The evaluate x to the fourth power evaluated at 4 minus evaluated at 1. So the result is pi by, the result actually is 85 pi by 3. 85 pi by 3. Okay? So this is number 3. Number 4, find the volume of the solid of revolution that is generated by revoluting the region about y-axis. About y-axis. About y-axis, so what's the formula? So the formula actually is Vy equal to the definitely equal from A to B. Here is what? 2 pi x fx. Yeah? So this is the formula, okay? This is the formula. So here the result actually is from 1 to 4. From 1 to 4, 2 pi x times 2 by 3 x 3 by 2 dx. So it's easy, yeah? So actually here 2 pi times 2 by 3 is 4 pi by 3 and x times x 3 by 2 power, so it's x 5 by 2 power. 5 by 2 power, so the antiderivative is 5 by 2 power plus 1 by 5 by 2 power plus 1. This is the antiderivative evaluated at 4 minus evaluated at 1. So the result is what? So the result is 1016 pi. 1016 pi by 21. So here, the students computer science? Hands up. So here, but who stand for others? We just have six. We just have 6 computer science students here, but here we have 7. So now, computer science student come here. Computer science student come here. Second, yeah?
That's childish, you know that. Okay, why are you checking? And then what?
So sit down. So whose major is food science? Stand up. Sit down. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah. So here we have another. So the students whose major is computer science and food science, you can leave, okay? The CV come here. CV come here.